In this video, we look at another example of using the ordinary annuity formula. This has been a recurring example right here with us that we were initially invested $500. We're making $10 deposits at the end of each month. And the question is, how much do you have at the end of 12 months? And in a previous video, we showed that this was $654.20 because we used the formula S is equal to the initial amount invested, 1 plus I to the 12th power plus the payment, 1 plus I to the 12th power minus 1 over I, right? Where P was the initial amount invested. Okay? And this, when you plugged in all the values, gave you $654. Just a quick check to show you how that's going to work in Excel. Okay, let me bring my Excel window in here. Okay, in Excel, you could just double check any of your answers by doing an equal sign in a cell and doing FV for future value. And you can hit the little FX button here, and that will bring up a box that you get to fill in the values for the rate. The rate is 0.06, and that it's the interest rate per period. So you need to divide this by 12. So the rate here is I, the interest rate per period. N per is the total number of payment periods in the investment. So we were trying to see how much we had at the end of 12 months or a year. And we made 12 payments in that 1 year period. The payment is $10. And PV is the present value. This is how much, for example, if you had any money to start with, which we did, we had $500. And the type here, since we're doing an ordinary annuity, you can see here at the top, Excel is telling you that payments at the end of the period, which is type 0, you get to put ordinary annuity as type 0. And the result of the future value here is the $654.20, which is what we got from our computation by hand. Okay, I'll leave your business professors to tell you about the difference between negative and positive numbers, but here just take the absolute value or just take the positive number, and that it's the amount that you have at the end of the month. Okay, so another example. Let's try to get into another example here. Let me bring in one from our class notes. Okay, we have an example where you're having $1,500 deposit at the end of each year for the next 6 years, and an account is paying 8% interest compounded annually. Find the future value of this annuity. And we have the answer here, but it'd be good to go through the steps. Okay, so let's go through that example. Okay, let me bring in. So here's another example. Okay, and evidently we had $1,500 being deposited at the end of each year, at the end of a year. Okay, we were going to run this for 8 years to see how much we would have. 6 years. How much we were going to have after 6 years. And the interest rate R was equal to 8%. Okay, and N was equal to 1 because we were compounding annually. Okay, which means that I, the interest rate per period, is R divided by N, which is 8% divided by 1. So you get 0.08. So R and N are the same in this case when you're R and I are the same when you're compounding annually. Okay, and we want to know how much we have at the end of 6 years. Okay, and it looks like we are just making deposits and we had no starting money in the account. Okay, so this example says no starting money. Okay, so we'll continue on. We now know that the question is, how much is the money in the account after 6 years? The book calls this value S, and what we need to do is use R times 1 plus I to the N. N is 6 in this case. We've made 6 payments in 6 years because we're making payments of $1,500 at the end of each year. Okay, minus 1 divided by I. Okay, so we need to fill in more of the blanks here. We had $1,500. Okay, we have to do 1.08 to the 6th power, subtract 1, and divide by 0.08. Okay. Let me bring in my calculator at this point so we can bring in the calculator. So I'm going to do this in a couple steps. We'll do 1.08 to the 6th power. I'll subtract 1. So that'll give us the 1,500. That'll give us the 0.5868. Okay, divided by 0.08. Okay, so we'll divide that answer. Divide it by 0.08. Okay, which gives you the 1,500 times 7.33593, and then multiply that by 1,500. 1,500 times that answer, and you get evidently $11,003.90. Okay, which was the answer that we were looking for. Okay, let's check. So we've shown how to do the formula. Okay, and we've shown how to do all the computations by hand. We know we've gotten the correct answer. Let's double check our answer here in Excel. Okay, the trick here was to use the rate was 0.08 divided by 1. So we're putting the interest rate APR divided by the number of compoundings is 1. How many times did you make payments in the time period? Well, it was for 6 years, and you're paying $1,500 at the end of the year. So you made 6 payments in that time period. You're making a payment of $1,500, and we had no money to start with. And we are making a type 0. This is a type 0 annuity, and there is the answer that we got using our formula, $11,003.90. 0.90. Okay, so that ends this example, and you should be able to do all the homework problems in section 5.3 now.